Hi everyone, welcome to the second episode. Today we will be talking about one-hot encoding. So what exactly is one-hot encoding? It is the representation of words as binary vectors. So you have a corpus of say 50 words, 100 words. For the sake of simplicity, let's just take a corpus of 3 words where you have cat, dog, and fish. So what you do is you create an array which will contain zeros and one, and your position of one basically is assigned, a unique position to one is assigned for a particular word. So for example, if you look at the screen right now, you'll see that the cat has the unique position of 1 as the first number, as the first place in the array, right? Similarly for dog, you assign it 1 at the second place, and for the fish at the third place. So each vector get represented has its own value of 1, and the rest of them are 0. So uniquely you see that each word has been represented by a unique array, right? And that's what one hot encoding is. Now to look at a bigger example, you'll see that here we have sentences: the cat sat on a mat, the dog chased the cat, and the mat was so soft and fluffy. Now this would be your corpus of sentences. What you can do is you can take unique words that are there in this corpus, and then for each word you can basically repeat the same exercise that we did for for this, right? Cat, dog, and fish. So here you see that each the will have its own will have the same kind of one hot encoder, but each word over here will have its own representation or its own position of 1, where this unique set of zeros and 1 combination, or the binary vector, represents a single word, right? So now these sentences, the cat sat on the mat, the dog chased the cat, and the mat was soft and fluffy, could basically be represented, where you see over here the sentence 1 could be represented as a collection of these arrays, and then similarly the sentence 2 could be represented as collection of these arrays, and similarly for sentence 3, right? So this was what one hot encoding is. But of course there are a lot of intricacies, a lot of drawbacks, and why we had to move beyond the one hot encoding, right? So the first issue was the sparsity problem itself, where it wastes a lot of memories, right? If you see over here, the sentences is just that there's one place or one that represents and then rest of them are zero. Now imagine if I have, say, 10,000 unique words, or 100,000 unique words in my corpus, right? How big the corpus would become, right? So how big the corpus vector would become, right? So it's practically impossible for us to represent a particular word, a huge corpus in these in these one hot encoders. So that was the first drawback. The second drawback was no word meaning or relationship could be found out. For example, dog and cat should be somewhat related, right? Or king or queen should be somewhat related to each other, right? Where they could be, the dog and cat could be clubbed together as animals, but there was no such meaningful relation or no word meaning which was attached to it. It was just a vector representation, a unique representation of each word, and that's it, right? And then the vocabulary growth problem. Suppose that I have these sentences: the cat sat on a mat, the dog chased the cat, and the mat was soft and fluffy. Now tomorrow if I add a new sentence to this, where I say the mat was very dirty, so now dirty, very, and dirty are two new words that are added. Now you need to then recalculate or recompute the entire one hot encoder, just because of two new words are added, because those two new words will have their own ones and zeros. So you need to increase the size of this particular list, right? And now you need to just basically recalculate the one hot encoders for all this words inside the sentences. So this is a problem, right? Because for every sentence that you add, you will have to recalculate, recompute the one hot encoders. So yeah, these were basically the reasons why we had to move to a better quality representation, and we would learn that in the next video. Share it with someone who would like it.